case where you use the trick, because number one, I don't think we've had them memorized anyway. But number two, if you don't have them memorized or you haven't done them in a while, which we haven't, how do we build this table? What's the pattern? Maggie? Okay, so like what would this be? Root 0 over 2, which is 0. This is root 1 over 2, which is 1/2. Very good. This is root 2 over 2, which we don't know what root 2 is. So we just leave it like that. This is root 3 over 2. And this is root 4 over 2. But root 4 is 2. So 2 over 2 is 1. So sines increase from 0 to 1 with those numbers. Cosines decrease from 1 down to 0. Just following that pattern backwards. So root 4 divided by 2, which is 1. Root 3 divided by 2. Root 2 divided by 2. Root 1 divided by 2. And 0. And then how do you get tangent? Look at that. Sine divided by cosine. And some of those are easier. Sine divided by cosine, 0 divided by 1 is 0. 1 divided by 0 is undefined. 45 is easy, even though the numbers look tougher, it's a number divided by itself. So anything divided by itself is 1. And then the 30 and the 60 are the ones where if you had to, could you do 1/2 divided by root 3 over 2, keep, change, flip, simplify, rationalize, of course. But does anyone remember what this one is versus this one? Radical 3 over 3. And these increase, so radical 3 over 3, and then this one is just plain radical 3. So we're going to need that, and I did it in degrees on the top. I'm just going to put the radian equivalent on the bottom, so there's 0, pi over 6, pi over 4, pi over 3, and pi over 2, in case they want the answer in radians rather than degrees. Okie doke. All right, so we're going to reference that table a lot. So in this first example, 1a just starts off reminding you basic. How would you solve an equation for x? You would try to get it all by itself. So 2x minus 1 equals 0. You just add your 1 over. This is just a linear equation. Divide by 2. And you get x equals 1/2. And you'd be done here. B is essentially the same equation, but a trig version. So we're not really getting x all by itself. We're getting the cosine of x, or the cosine of theta in this case, all by itself, using the same properties. So our focus is get the cosine of theta all by itself, the same way we got x all by itself. You're going to add 1 over. And divide by 2. And we're looking for where the cosine of theta equals 1/2. Okay, the table is only going to give you your reference angle. And by the way, they're asking for your theta in terms of degrees or radians? Degrees. So we'll use our degree numbers. So what is the reference angle? We'll start there. When does cosine equal 1/2? 60 degrees. So there's your cosine 1/2, 60 degrees. Okay? Now, the trig concepts that, it's been a while, that we have to remember are, we want any and all, and that's where this is different than just a linear equation. There's multiple answers. We want any and all angles between 0 and 360. So really, we're going to go around one full revolution and look for any place where the cosine equals positive 1/2. Starting with the positive, what two quadrants are we going to stop in? Where is cosine positive? 1 and 4. So in the first quadrant, our reference angle of 60 would be a 60-degree angle. Yes? So because that's quadrant 1, theta could be 60 degrees. And then the second quadrant, we don't grab that reference angle of 60 because cosine would be negative there. Cosine would be negative again in the third quadrant. We want cosine to be positive. And so we keep going, and we do have to stop in the fourth quadrant and grab that angle. What is the angle in the fourth quadrant that has a reference of 60? I hear 240. I hear 270. Is that what you said? I hear 300. I hear... So let me get out my bobby pin. This is 0, right? This is 90. This is 180. This is 270. So, Connor, we've already passed 240. And then we want to go, this is 360, but we wanted to be how many degrees shy of 360? It's 0 degrees, 90 degrees, 180, 270, and this is 360. Our reference angle is right here. That's 60. So if the full circle is 360, we have to back it up 60 degrees. 300 it is. Follow? So there are two answers. Theta equals 60 degrees or theta equals 300. Good? Okay, if you look at 2a and 2b again, I like the way that she did this because she's showing you kind of linearly, without letting trig confuse you, what would you do here? You'd have to get all of your x's together, right? So maybe you would just subtract this x over to the left if you're one of those people that likes to keep your x's positive. And then you'd get rid of your radical 3, right? You'd move that to the other side. So you consolidate your x's, subtracting that over, and then get rid of your constant, subtract your root 3 over. You'd be left with x equals negative root 3. And you'd be done because you were just solving for x. Versus in b, you're trying to solve for theta. You have to get all of your tangents together. So 2 tan theta on the left, and we also have a tan theta, a 1 tan theta on the right. I'm going to subtract this tan theta over. So I have 1 tan theta, and I'll slow this one down and keep my root 3 over here for just a second. So I just got all my tan thetas together. And then I'm going to subtract the root 3 over to the other side to get tan theta all by itself. Just like I would get an x all by itself. So far, so good? And once that sine, cosine, or tangent is all by itself, find your reference angle. So the reference angle is what? When does tangent equal root 3? 60 again. And do they want, look at your thetas, do they want it in degrees or radians? Radians. So rather than 60 degrees, we'll say pi over 3 is our reference angle. Good? And then we have to find the angles that have that reference angle in the appropriate quadrants. So your quadrants we're looking at when tangent is negative. So what quadrants are we looking at? When tangent is negative. Did you say 1 and 2? Everything's positive in the first quadrant. So if we're looking for where tangent will be negative, that's out, and that's out, because tangent's positive there. It's 2 and 4. So what is the angle that has a reference of pi over 3 in this second quadrant? So if this right here is pi over 3 as your reference angle, how do we label this one, first of all? 3 pi over 3. Good, Maggie. So what is one like tick prior to 3 pi over 3? 2 pi over 3. So theta equals 2 pi over 3. And then if you did a full circle, Maggie, how would you label this? Yeah, but in terms of the over 3. 6 pi over 3. So if we want a fourth quadrant angle with a reference of pi over 3 here, what's one tick prior to 6 pi over 3? Kind of picturing that terminal ray swinging around. 0 pi over 3, 1 pi over 3, 2 pi over 3, 3, 4, 5, and 6. So that would be 5 pi over 3. The tough part about this is that there's not really much work I can document. It's not just on paper where all of what just happened here is very mental in visualizing. And I'm doing it and I'm showing it and I'm explaining it. But when you go back, if you're just looking at your notes, you might get here and think, I have no idea how this just happened. Go back and watch the video and listen to it again, because the work really can't be shown. It can only be seen and thought of and explained. Okie doke. We stopped our linear side-by-sides. Bummer. What would we do here? What's your gut, Bean? It's in degrees. Perfect. We're not quite there yet, but it's good to know. Pay attention to that. When we do grab our reference angle, we'll grab it in degrees. Cosecant. Well, I do need to get my cosecants together, but there's an obstacle in my way of that. What do you think, Maddie? Distribute the 3 first. So then you have 3 cosecants minus 3 equals cosecant plus 2. Now I can start subtracting cosecants around. Again, I like to keep these things positive, so I'm going to subtract this one over. So 3 cosecants minus a cosecant will leave me with 2 cosecants. So I'm getting my cosecants on the left, which means this negative 3 I want to add over to the right. So that equals 5. Good. Divide by 2. And so we don't really have a button on our calculator for cosecant. We also don't have values on our chart for cosecant. Yes? So we have to change this to sine first, sine being the reciprocal of cosecant. So if the cosecant is 5/2, the sine is what? 2/5. So the unfortunate part about this is it's not on our chart. And fortunate, maybe that's not unfortunate. Maybe that's fortunate because you need your calculators. So what do I type in here to get my angle? Inverse sine. Now think with me for a second. When I do inverse sine, what's the range of inverse sine? It's always going to give me an angle in which 2 quadrants? Either what or what? Nope. Inverse sine is 1 or 4. So is inverse tangent 1 or 4. Your calculator is never going to give you all the answers. It's just going to give you one of the answers. Do you follow? And it's going to give you the answer, whatever it is, between negative pi over 2 and positive pi over 2. From there, we have to find our own reference angle. And once we have our reference angle, we have to find the other quadrant where sine is positive. Yes? So between the inverse sine range, we'll call it, which quadrant is it going to give us if sine is a positive 2/5? It's going to give us a first quadrant answer. So inverse sine of 2/5, and we want to be in a mode of degrees or radians. degrees, so make sure you're in the right mode. .578. Let's, just for the sake of not overcomplicating this, let's round that to the nearest degree. It'll just make it easier. So we'll say 24 degrees. Approximately 24 degrees. So they are giving us a first quadrant answer of 24 degrees. And that is true. Sine is positive in the first quadrant. So what is the reference angle then? The reference angle is this one right here, which in this case does coincidentally also happen to be 24. Okay? Yeah, the first quadrant one is always, yeah. And so where's the other quadrant where sine is positive that we have to find on our own? Quadrant 2, right? Sine is also positive in quadrant 2. So if we have a reference angle of 24, here's 0, here's 90, and here's 180. If I have a reference angle of 24, that means I need to back this up 24 degrees. So that would be 180 minusing 24 degrees to cut you back into the second quadrant. Does that make sense? So 180 minus 24 is 156 degrees, and that would be your second quadrant answer. So the calculator gives you the 1, and that's great, but you have to find the other one. So I'm just going to write theta equals 24 degrees and 156 degrees. Good? Okay, last one here. 3 sine plus 5 equals sine. JR, what would you try first? I would, yep. Subtract sine. Do you want to do anything else at the same time, or is that just good? So 2 sine of theta equals negative 5. Bean, what would you do next? Yep. So sine of theta equals negative 5 over 2. Again, not something we can steal from our chart. So we'll do inverse sine of negative 5 halves. Now, it's inverse sine again. Correct. I had to think about why that was, but first of all, if you were expecting an answer in the first or fourth quadrant between negative pi over 2 and positive pi over 2, which one would it be if sine is negative, right? If anything, we're expecting some angle in here, right? Now, the reason it gave us that is because essentially we're looking for where the sine of theta equals, what's negative 5 halves as a decimal? What's 5 divided by 2? Negative 2.5. Sine values always oscillate between what two numbers? What's the lowest a sine value is ever going to be? Negative 1. And the highest it's going to be is positive 1, right? We're trying to find where the sine graph ever reaches negative 2.5, which would be down here somewhere, and the answer is never. That's why your calculator gave you an error. If you ever try to find inverse sine or inverse cosine of a number that's greater than 1 or less than negative 1, you're always going to get an error for that reason. Does that make sense? So, not anything to be totally thrown off by, but understand a little bit where that comes from, why it does not exist. One more thing for you, because this will probably come up and you're going to want to know it. Let's pretend I have something like this. Cosine of theta equals negative 4/5. Okay, when I do inverse cosine, what quadrants am I limited to there? Do you remember? Sine and tangent are 1 and 4. Well, sine and tangent are 1 and 4, but cosine is 1 and 2. Because the first quadrant will cover where cosine is positive, and the second quadrant will cover where cosine is negative. Yes? Okay? So I'm going to get an answer between 0 and 180. Let's keep this in degrees. Because cosine is negative, which quadrant do I expect the calculator to give me an answer in? 2, for sure. So do inverse cosine of -4/5, and I'm given a 143 degree angle. Now this is trickier because we have to come up with our own reference angle. The calculator gave us the answer from the second quadrant, which was 143. We did not get the reference angle, though. In order to find the other one, we have to come up with it ourselves. The reference angle is right here. It's the difference between 180 and 143, and Connor, I think you said it, 37? Yep. So the reference angle is 37. Now we need to use that reference angle to find the other quadrant where cosine is negative, which is which quadrant? Where cosine is negative. All students take calculus. Cosine is positive here. Where's cosine negative? Good faith, the third. So we need an angle in here that has a reference, here's your reference, of 37. So that would be 37 degrees past 180. So 180 plus 37 is 217. So you'd have two answers still, but the reference angle is not one of them. So that's a little trickier. Inverse sine and inverse tangent are nice because they're either going to give you the positive version of the reference angle or the negative version of the reference angle, but at least the reference angle is staring you in the face. Inverse cosine, if it's a negative especially, it'll put you in the second quadrant. You have to come up with your own reference angle. Good?